Hi, my name's Cale Plut. I'm a PhD student at the Meta Creation Lab at the School of Interactive Arts and Technology here at Simon Fraser University, and this is my 3-minute thesis video on affective generative music in video games. Video game music shouldn't be possible. You see, music is linear. A piece of music starts at the beginning, goes through the middle, and gets to the end, and even if it's played multiple times, it will do the same thing, mostly. Games, on the other hand, are interactive. One player might turn left at the end of a hallway, another might turn right, and from those decisions, further decisions branch out. Video game music shouldn't be possible. How can we write a single linear piece of music that in any way feels like it fits with and goes with the infinite possibilities of gameplay? Well, there is a technique for this. It's called adaptive music. It comes mainly from the games industry. Basically, it refers to composers can write music in some specific constrained ways where the game can actually cut up and rearrange those pieces so that they somewhat match what's happening in the game. This is an incredibly powerful tool for helping music match gameplay, but it does have a couple of drawbacks. The first drawback is that writing adaptive music takes a lot of extra time and work and labor compared to writing a single linear piece. Secondly, because of the musical constraints placed on the music so that it can be rearranged in different ways, the composer might feel that their expressive range is reduced compared to what they might be able to express with a linear piece of music. At the Meta Creation Lab, we're trying to use a field called Computational Creativity to address some of these issues. Computational creativity basically refers to the use of artificial intelligence models and systems to address creative tasks, such as creating a painting, or in this case, writing a piece of music. Computationally creative systems have a couple of advantages that we really want to exploit to help shore up the weaknesses of adaptive music. First, these computationally creative systems can write music very fast, depending on the system. Some systems can write music so fast that they can actually write music while it's being played in real time. Secondly, these systems can have a much more complete understanding of musical constraints because they can be trained specifically on those constraints and have a little more freedom navigating the possibility space than a human composer might. In theory, at least. The only question remaining really is how can we get the video game to talk to the music generator? And for that, we use emotion. You see, in film, music is often used to enhance the emotional impact of a film, and we want to do the same for video games. We've designed one emotion model that fits into a game and looks at what's happening in the game and tries to describe the emotion that we feel or that the model feels the game is expressing. We then take that emotion and are feeding it into a music generation system. Now, we're currently training this system to generate music based on an emotional input. In theory, the end result of this will be a system where the user can play a video game and the music will react to match perfectly the emotions expressed by that game. Thank you for your time. My name is Cale Plut.